Okay, today's notes are going to review an introduction to log functions. And so you're going to practice going back and forth between the log form and the exponential form of a variety of things, and using just that process to do some basic solving as well. So I just want to remind you guys that this is all a review from Algebra 2, so I may move a little quickly. You can always pause and rewind if you need to, if I'm going too fast. So I want to remind you that a logarithm is actually nothing more than an exponent. Too close to the top. Because that's what reading a log is actually asking you for. It's asking you to find an exponent for something. Now, to go back and forth between the two forms, some teachers teach the lasso method. So if you have a base being raised to an exponent and you get a number as your answer, then to go into the log form, you lasso the base and you swing around through the number and the exponent. And so what that is supposed to tell you is that the base comes first, and then the number comes next, and then the exponent comes last when you switch into log form. What you really need to remember is just the base of your exponent is going to be the base of your log. So I use the annoying phrase, the base is always the base, because we're also going to be using the change of base rule, which has the same thing. The base is going to be the number in the bottom of that rule. And then the exponent and the number will switch sides of the equal sign because these functions are inverses of each other. So the x and y switch. Your base and your number both have to be numbers bigger than 0, and your base can't be equal to 1, because if your base is equal to 1, then it doesn't matter what number you raise that 1 to, your answer is always going to be a 1. And so if I asked you to do a log with a base of 1, first of all, the only number that could go inside of it would automatically be a 1. And then you would have an infinite number of answers to choose from, because this is asking you 1 to what power is 1. And I mean, it could be anything. It could be 0, it could be -3, it could be 10. You would have an infinite number of answers, so there would be no way to answer that question. So your base can't be equal to 1 for that reason. So the first thing we're going to practice is just going from exponential form into log form. So if 11 to the power of 3 is 1331, then as a log, the base of the exponential was 11, so the base of the log is 11. And then the 3 and the 1331 will switch sides. So the 1331 is going to go inside the log, and the 3 is going to go on the other side. Now keep in mind that when you do quiz on this, one thing you will need to be able to do is evaluate problems that just look like this. And so you need to learn to read these to yourself as a question. It's got to be 11 to what power is 1331? That's the question that it's asking you. So 11, oops, I'm still in erase mode. 11 to what power is 1331? That's what that log is asking you, which is why the answer is 3. So it's equal to 3, because 11 to the power of 3 is 1331. So number 2 would be a log. The base of the exponential is 4, so the base of the log is going to be 4. And then the 2 and the 0.5 will switch sides. And you can write it as a fraction if you want to, or you can leave it as a decimal. And so remember that once again, one of the things you're going to be practicing and eventually quizzing over is being able to answer the question, 4 to what power is 2? Because that is what this log is asking you. And that's why the answer is 0.5, because a power of 0.5 is a power of 1/2, which means square root. Okay? So take a split second and write number 3 in log form, please. Okay, hopefully what you did is you did a log. You put the 2 as the base, so log base 2 of 32 is 5. So the 2 stayed the base, and then the 5 and the 32 switched sides. Or you can always, as always, I know a lot of the other Algebra 2 teachers, they do that lasso method. So 2, and then 32, and then 5. So you can swing around like that, and that's fine. The reason I don't use the lasso is because it doesn't help you convert into change of base form. Okay, so now going in the other direction, remember, I'm going to kind of scratch this out just for a second. Remember how to read this log. This is saying 2 to what power is 16? Okay, and that's why the answer to this is 4, because of the fact that it's 2 to the power of 4. That is 16. So there's its exponential form. So number 5, the way we would read this is log base 3. In fact, we have log base 3 of 1/9. That's how we read it. Okay? And it's asking you, if we covered this part up, if I give you on the quiz next week, if I give you a problem that looks like this, it's asking you 3 to what power is 1/9. So you would have to figure out what power would flip the 3 into the denominator and square it, and your answer would be -2. And that's why this log equation would convert its exponential form. Oops, meant to be in erase mode. Its exponential form is 3 to the power of -2 is 1/9. Okay, so by default, this right here, number 6, would be 10 to the power of 5 is 100,000. Okay, so going back and forth between those forms allows you to do actually quite a bit of the solving in this unit. So you're going to have a couple of different situations that arise. So number 7, the variable you're trying to solve for is inside of the log. So when you convert it to its exponential form, so 10 is your base, the exponent would be the -3, and it's equal to x. And simply converting it to its exponential form has solved your equation. The only thing you would need to do is you would need to actually evaluate what is 10 to the -3. So if you took that 10 and you flipped it over and cubed it, you would have 1 over 1,000. Okay, so that's what happens when your variable is inside of the log. Okay, simply converting it into exponential form will solve it. Then if you look at number 8, this time the variable you're trying to solve for is your base. So when you convert it to its exponential form, so your base is x, so your base is going to stay x. And then whether you do the lasso or whatever it is you need to do, I just switch sides of the equation for those other two numbers. So the 3 halves is now inside of my equation, and it's equal to the 216. Okay, well, so this time the situation you run into is that now this is a power equation. And the reason it's a power equation is because your variable is being raised to a power. And you've actually already had to solve 1 or 2 of these on the homework from last night. So in order to get rid of an exponent of 3 halves, we need to raise both sides to the power of 2/3. Because this power times this power would cancel out and just become a power of 1. So x is now by itself. Now, as far as evaluating 216 to the power of 2/3, you could square first. You could do the 216 squared, because that's what that numerator is telling you to do, and then you could take the cubed root. I don't know why it keeps resizing. I don't know how to fix that. There we go. Okay. But that would make it quite a bit harder to answer, because squaring 216 is going to make it huge, and then you cubed root it would just be exceptionally hard. So you can go in the other order. You can do the cubed root first, so x is equal to, do the cubed root of 216 first, get an answer from it, and then take that answer and square it. So you can raise your powers to whatever order you need to first. Okay, so the cubed root of 216 is 6, and then you would square it, and so your final answer would be 36. Okay, and then number 9, you can convert it to its exponential form, but remember there was a rule. The base and the number inside the log have to be bigger than 0, and so this automatically means no solution. Now the reason that it means no solution is because if you convert it to its exponential form, then it would be 7 to the power of x is equal to 0. And there is no power that you can raise 7 to make it become a 0. So that's why there's no solution. Okay? And then number 10, you could convert it to its exponential form, and then you would solve it the way we did our exponentials that had the same base, or you could just learn to evaluate it. So if I cross this off for just a split second, remember how to read this log. This is saying 5 to what power is 1 over 125. So some people are going to be able to simply just look at it and know, oh, that 5 got flipped and it got cubed. So my answer is -3. But if you need more practice with reading those logs and evaluating logs, then what you do is you convert it to its exponential form like the previous 3 problems. And its exponential form would still have a base of 5. The x would move inside the equation, so it would become the exponent, and it would be equal to 1 over 125. And as soon as you do that, it becomes like those exponentials we solved where we had the same base on both sides. So I've got a 5 to the x over here. 1 over 125 is 5 to the -3. And so I have 2 exponentials that are equal to each other. Their bases are identical, so I can drop the bases, and my solution is still -3. So it's only like 2 steps of work if you can't evaluate that just outright, just by reading that log. Especially like on number 11. If you look at number 11, like I said, you could just evaluate it. You could look at it and go, oh, 4 to what power is the 4th root of 8? That's a pretty complicated one. And so I would actually recommend this time that you go ahead and convert to exponential form. So exponential form, the base is going to be the 4, because remember the base is always the base. Okay, and then the other 2 switch sides. So the x moves inside the exponential, and then the 4th root of 8 moves to the other side. Now I can rewrite both sides as powers of 4, I can rewrite both sides as powers of 8, but I think for most people it's going to be easier to do as a power of 2, because both sides are powers of 2. So I'm going to rewrite both sides as a power of 2. So my 4 is a 2 squared, and it was being raised to the power of x, so it becomes 2 to the 2x. And then my 8 is the same thing as 2 cubed. And don't forget that this 4th root right here, I could have rewritten it. It's the same thing as the power of 1/4. So that means my right side becomes 2 to the power of 3/4. Okay, because it got cubed, which is what made it the 8, and then it was under a 4th root, which is that denominator of 4. And now I have 2 exponentials that are equal, their bases are identical, and so I can drop the bases and just have 2x is equal to 3/4. And then when I divide by 2 to solve it, I get x is equal to 3/8. Because remember, dividing by 2 is the same thing as multiplying by 1/2. So if necessary, I know that some people do still struggle with taking a fraction and dividing it by an integer. So instead of dividing by 2, I could have just multiplied both sides by 1/2, and that's how I got the 3/8. Okay? And so I want you to take a second. I want you to try number 12, because number 12 is the same type as 10 and 11. Go ahead and pause it for a second, because I'm going to give you a little bit longer to work this one. Okay, hopefully you paused it, and you rewrote in exponential form, so 27 to the power of y is 81, and both sides are powers of 3. So 27 is 3 cubed, which made your left side become 3 to the 3y, and your right side just became 3 to the 4th, and you dropped the bases, and so 3y was equal to 4, which means y was equal to 4/3. Okay? And then the final row of solving are more of your power equations and more of your no solution kind of equations. So on 13, when you convert to exponential form, you get x to the 1/4 is equal to 3. And so that means that to solve it, you need to get x by itself, so you need to get rid of that exponent of 1/4. So you raise both sides to the power of 4. And those two powers will multiply together and cancel, just become a power of 1. So x is by itself, and 3 to the 4th is 81. And so there's your answer. And 14 is another no solution one. Remember that you do have that rule that you can't, your base of your log and your number inside your log both have to be bigger than 0. So we've already violated that rule. But the reason is the same as it was up above. When you convert to exponential form, this would convert to 4 to the power of x is -16. There's no power you can raise a positive 4 to make it become a negative number. So this is no solution, whether you show converting it to exponential form or not. So some people will just be able to look at it and evaluate that log and just get no solution to that. And then on 15, we have exponential form where the base is x, remember, because the base is always the base, to the power of 2/3 is equal to 81. So to solve it, we need to get rid of that power of 2/3. So I'm going to raise both sides to the power of 3/2. Okay, so I cancel those two powers out. They become an invisible power of 1. And 81 to the 3/2. Remember, the denominator of 2 means I'm square rooting. So I could do 81 cubed and then try to square root it. But that would be really messy, right? So what I'm going to do instead is I'm going to square root the 81 first, and then I'll cube it. Okay? You notice that I'm not doing the plus or minus for that square root, because remember, I'm solving for the base of a log. And the base of a log can't be a negative number. So I don't need to worry about the negative solution to this. So x is equal to, the square root of 81 is of course 9. And then when you cube it, you get 729. Okay? And the final two things to remind you of are that there are two logs that have buttons on your calculator. We do use them fairly frequently. The common log was used a lot more in Algebra 2. We use the natural log an awful lot in pre-cal. So the common log is a log with a base of 10. So if you ever see a log base 10, let's do something simple like 100. Okay, it's not going to be written like that. You're very rarely, if ever, going to see that base of 10. The way that we would just write it is we would just write it as log of 100. Okay, there's an invisible base of 10 there. And remember what this log is asking you. It's asking you 10 to what power is 100? And so the answer to that would be 2. So you would evaluate log of 100 as being equal to 2, which if you look right there, that's what it's saying. Okay, so what this one right here, for example, is saying is it's saying log base 10 of 1/1000th. And once again, you're not going to see that 10 most of the time. The way we will give it to you is just log of 1/1000th. Okay, and that is asking you 10 to what power is 1/1000th. And so the answer to that log would just be -3. Okay, so that's a common log. And it's called a common log because it does occur incredibly commonly in science and math applications, but mostly at the Algebra 2 level. Our logistic models are Newton's law of cooling. and our continuous interest and all those kinds of applications, we use E. So we use natural log a whole lot more at the pre-cal level. So the actual mathematical definition of E is it's the sum of 1 over n minus 1 factorial starting with 1 and going to infinity. Okay, you notice the ellipsis at the end, the dot, dot, dot. So if you did 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, you would be calculating E. Okay, now you're never going to have to memorize that. E's got several buttons on your calculator. It does have an approximate value of 2.7183. Okay, but I mean, it's because it's got buttons on your calculator is going to use all of the digits of it, so you don't need to have it memorized, but this is just giving you an approximate idea of what the value is worth. And when we have a log with a base of E, sometimes it'll have a power of E inside of it. Most of the time it'll just have some random abstract number like, 10.573. I'm just making up a number, 1, okay. So what this is asking you is E to what power is that number? And it would require a calculator. It's not a perfect power of E. Okay, but you're not going to see it written as log base E. You're going to see it written as natural log of 10.5731. Okay, so natural log is a log with an invisible base of E. So it's just a reminder about those two logs that have buttons on your calculator. Okay, and we'll be using them over the next few days to refresh your memory some more. Okay, so I know this went a little bit longer than had intended, but hopefully this has refreshed your memory about logs. Tomorrow's going to be a day in class to practice using these laws, and then the day after we'll start working with our properties of logs. So we're trying to spread it out. Come see us if you need tutoring and ask questions in class. We'll see you guys later.